So everybody on slide 2? We'll meet on slide 2. I'm going to zoom in a little bit. All we're talking about here is Pythagorean theorem. What is Pythagorean theorem? Absolutely, right? And we've got some Pythagorean triples that are always whole numbers, right? So 3, 4, 5, 5, 12, 13, 8, 15, 17. So let's put one of each of those in these 3 boxes. So I'm just going to zoom in a little bit so I can see it a little bit better. This is a lot on a page, right? So our first triple was that 3, 4, 5, right? So we're just going to type in 3 squared plus 4 squared equals 5 squared. That's Pythagorean theorem. So if we solve that, that's going to prove that those 3 sides make a right triangle. So 3 squared is 9. 4 squared is 16. And 5 squared is 25. Is that a true statement? 9 plus 16 equals 25?
Yeah, that's true.
Yeah, that's true. So I know that's a good Pythagorean theorem. Those work. So I can draw a triangle underneath. 3 tall, 4 wide, and if I close it, that diagonal should be 5 if I got my ruler out and measured, right? So all I'm doing is drawing right triangles, labeling the sides, proving them with Pythagorean theorem. So what's another example I could do for Pythagorean theorem? What's another triple? 6, 8, 10. All I do for 6, 8, 10 is double it, right? 6 squared plus 8 squared. Oops, that's an equal sign. 10 squared. So 6 squared is 36. And 8 squared is 64. And 10 squared is 100. Does that work? Yeah, 36 plus 64 equals 100, so that works. My triangle is going to be twice as tall. Instead of 3, it's going to be 6. Instead of 4, it's going to be 8. I don't know if that's actually 8. We're just going to call it 8. And then instead of 5, it's going to be 10. I did a scale factor of 2 to make it twice as big.
Wait, 36 plus 69 equals 100.
Plus 64. 8 squared is 64.
Oh, it's a 4.
Yeah, that's a 4.
Oh, so
I'm glad you called me out. And remember, your hypotenuse is always the longest side. Both of those are in the same family. That's why we can use a scale factor. 2 times 3 is 6, 2 times 5 is 10, 2 times 4 is 8. The pink one is just half the size of the blue one, or the blue one is twice as big as the pink one. If we come over here, let's use 5, 12, 13 instead. That's a new family. 5 squared plus 12 squared equals 13 squared. So 5 squared is 25, and 12 squared is 144. 13 squared is 169. And that is a 9. Does that work? 25 squared plus 144, is that 169? Yeah. So Pythagorean theorem works. It's always good to test it. And then we can draw our triangle. So that's 5 by 12, which would close into 13. 5, 12, and 13. That light blue is so hard to see. with a right triangle and a hypotenuse that's always the longest side. Questions on that? No. I think underneath it asks us to use a scale factor to make 3 other Pythagorean triples. So what could I do with a 3, 4, 5 triangle to make it bigger? What scale factor could I multiply those numbers by?
Just like any number?
Yeah, any number.
Oh, well, that one's 2.
It is, we've already used 2. How about if we use 3? Okay, so if I make a scale factor of 3, I want to increase that 3, 4, 5 triangle 3 times. What would be my new side lengths? 3 times 3 is 9, and 4 times 3 is 12, and 5 times 3 is 15. Voila. We could do a scale factor of 10. What would my 6, 8, 10 triangle turn into if I did a scale factor of 10? You got it. 60, 80, and 100. The ratio of all the sides is going to be the same. It's the exact same triangle. It's just bigger, right? So they're similar. What about the 5, 13, 12, or the 5, 12, 13? What scale factor do we want to use there? We just need to choose one. Any number between 1 and 10. 6. Okay, so if I use a scale factor of 6 on this, what math do I have to do? 5 times 6 is 30. And 12 times 6 is 70. And 13 times 6 is sweet. So scale factor just makes all the sides grow at the same rate. We ready to go to slide 3? Slide 3 is just notes. I think 4 is just notes too. But I don't want to rush you. You ready? Okay. So slide 3 just kind of reviews what we've already talked about. This is legit the formula sheet if you were going to take the SOL. None of you have to take the SOL. So we've got Pythagorean theorem. We've got our trig ratios. If I give you a side and an angle, and I want a side, right? We can use trig. This is I give you 2 sides, and I want a side. So over on the right side, all we're doing is labeling that triangle. So I have a right angle, and let's make this acute angle, really acute angle X. Where do I put the 5? Where's the opposite side? At the top, at the left, or on the bottom? The top, yeah. So if I go straight through the triangle, that's the O. So that's going to equal 5 because opposite is 5, right? Opposite is 5. And then the hypotenuse is 13. Where do I find the 13? Across from the 90-degree angle. That's going to be the H. which means the other side is going to be the A, right? So A equals 12. So all I did was take these ratios that were given to me and apply them into a picture. We've always gone the other direction so far. Today will be the first day where I give you a ratio and I want you to put it on a picture instead of taking a number off of the picture and putting it into the ratio. So this is kind of new today. But it's still O, A, and H. It's just going the other direction. Am I going to have a mutiny if I go to slide 4? Are we going to be okay? It's kind of a review of everything we've learned except that one little piece. Okay. So if we go to slide 4, we've got two different kinds of right triangles. We've got 30, 60, 90, and we made little hashtags for these probably like a week ago now. And we did the relationship between the small side opposite the X, or opposite the 30 degree, and the hypotenuse was what? How much bigger was the hypotenuse than the short side? The small side was half of the long side, exactly. Or the long side was double the short side, depending on which way you're looking at it. So if this is X and this is 2X, then that middle one, because I've got 3 different kinds of angles, is going to be X on the square root of 3. X square root of 3. So if I know this is 1 opposite the 30 degree angle, and this is 2 opposite the 90 degree angle, then this is the square root of 3 opposite the 60 degree angle. This ratio will always stay the same. It will never change. It might get scaled up or scaled down. Maybe it's 7, 14, and 7 on the square root of 3, but the basic ratio is always going to stay the same. It says X on the square root of 2. So it says X, or X on the square root of 3, X on the square root of 3, and 2X. That's that middle line right there. You are welcome. For the 45, 45, 90 triangle, we've got a similar ratio, but it's a little bit different. We know that our legs are going to be exactly the same because these 45 degree angles are exactly the same. So we'll make both of those X. And then because I have 2 angles that are the same, that hypotenuse is always going to be just X on the square root of 2. X on the square root of 2. So if I've got 1, 1, it's just going to be square root of 2. So this line in here is X, X, X on the square root of 2. And we're going to practice that a lot today, so you'll get good at that. So question 5 puts those things into perspective, right? So if I've got my 30, 60, 90 with X, 2X, and X on the square root of 3, because there's 3 different angles, what's the 14? What's that opposite? Is it opposite that 90 degree angle? So that's the 2X, right? That's that hypotenuse, that longest side, absolutely. So what's the shortest side? What's that going to be? The 30 degree one. If the hypotenuse is twice as long as the shortest side and the hypotenuse is 14, what's the shortest side? As a number. 7, absolutely. So I've got X and 2x and 14 and 7. So this is going to equal 7. And then opposite that 60-degree angle is x on the square root of 3. So 7 on the square root of 3. You could also do Pythagorean theorem if you get to this point and you're not sure about that square root of 3. Do a squared plus b squared equals c squared. I know my c is 14. And I know my a is 7. So then you just subtract b squared equals 14 squared minus 7 squared, and you're going to get the exact same thing. It might be a decimal, but it's going to be the same thing. Kind of, sort of, maybe. I can. So we did these with the cranes, I think. We did them all together. I do kind of want the answers on your pair deck. Yeah. These are kind of like your notes. So in an ideal world, I want you to be able to answer these questions. So when you go to take the SAT, you'll be able to answer some of these questions. These are SAT questions, yeah. You're not going to fail. You're not going to fail. The geometry questions on the SAT are really hard. You don't have an SOL. SOL is for Virginia to graduate high school. SAT is usually required by colleges to get into college. So usually you take the SAT at the beginning of your senior year or the end of your junior year. I usually encourage students to take it after they take Algebra 2. Can't you take Algebra 2? You can. Mm-hmm. Yeah, next year you'll be in Algebra 2. I wouldn't rush it. There's a lot of material in Algebra 2. Are we ready to look at number 2? What kind of triangle is number 2? It is a right triangle. What kind of right triangle? It is an isosceles right triangle. So if this side is 8, what other side is 8? BT is 8, absolutely, because this is 45 and this is 45, right? So we can 100% do Pythagorean theorem. You have two sides, so you can find the third side with Pythagorean theorem. Or if you remember the 45, 45, 90, and x on the square root of 2, then if this is 8 and this is 8, this is just 8 on the square root of 2. Pythagorean theorem works just as well. So if this makes the hair on the back of your neck stand up, which I totally get, do a squared plus b squared equals c squared. And we can do 8 squared plus 8 squared, those are our legs, equals c squared. And then we come over to our calculator. And I already have 8 in there, so I can just put in an 8. 8 squared plus 8 squared equals 128. So then I come down here. That's not what I want. Square root of 128 is going to be 11.3. It makes you realize you have a brain inside your head. Smart guy. So a lot of people think, yes, this is easier. The benefit and the whole reason why we do this with the square roots is to get it precise. So a couple years ago, probably more than a couple years ago now, I did an internship over at the shipyard. I know Elif said her dad works over there. A lot of the things that they build for those aircraft carriers have to be within 10 thousandths of an inch. So that's like 5 decimal places. The only way to get that precise is to use TRIG and use those radicals.
But even if you do this, doesn't it give you things that answers
It will until you start multiplying and dividing and rounding with it. It's the rounding that's the problem. So that's why I'm giving you options. For our purposes, these are exactly the same. If you're not going to be an engineer, a mechanical engineer, an aeronautical engineer, you don't need any. This is definitely close enough, right? You're going to build a fence in your backyard. You're going to build some kind of like cornhole game for your grandma. Like, this is going to be close enough, more than close enough. Oh, Sterling. So let's do a couple more of them. I think the next two are going to be fairly easy, and then slide 7 is going to stress you out. So just prepare yourself mentally for it. We're building brain cells one geometry question at a time today. Yeah? Sterling, do you know that you can, well, it's not really any different than working on Pear Deck, but Screencastify, that's what I'm using. It's a free Google app, so you can download that so you can write on it, but it's still not a stylus and a touch screen. I gotcha. And it's slow going. I get it. You can definitely do it on paper. I have almost an entire 200 sheet notebook full of like handwritten stuff for this year. I've used more paper this year than ever before. So if we go to slide 6 and we look on the left side at number 3, what other information can I fill in there? So I know this is 5 square root of 3, and that's opposite my 30, right? So if that's opposite the 30, that 5 square root of 3, which side should be double that? Which side should be double that? If the 5 square root of 3 is my smallest side, which one should be double that? It is, yeah. So this side should be twice as big. So that should be 10 square root of 3 because it's going to be twice as big. 10 square root of 3. And then for the last one, we just substitute. So we know what x is. That's 5 on the square root of 3. So this is going to be 5 square root of 3 times another square root of 3. We need this square root of 3 in there too. So put that in the calculator. There's no need to stress our brains over that. 5, and then square root of 3, and square root of 3 more. And what do you get? Okay. And then 5 on the square root of 3. You don't have to do it this year. You would. And then do one more square root of 3. So 5 times the square root of 3 times another square root of 3 is going to be 15. So that's V. Yep. So this is X, this is 2X, and this is X on the square root of 3. And we said X equals 5 on the square root of 3. So we just substituted that in. 5 on the square root of 3 times the square root of 3. And then 5 on the square root of 3 times 2. It is a whole lot easier to look at without those radicals, without those square roots. I love it. Don't stress out about tomorrow. Worry about today. Let tomorrow take care of itself. Tomorrow will be just fine. So try to make a little hashtag over next to number 4. You can use your line tool. You can also put in text boxes. You don't have to be drawing these. You can just put them in text boxes. You're going to put in the 3 angles. So 45 and 45 and 90. So 45 and 45 and 90. Okay. The 2 sides, the legs, are going to be X. So underneath the 45, put X and X. Because it's isosceles, absolutely. Got 2 sides that are the same. So over on this hypotenuse, it's going to be conveniently X times the square root of 2. So whatever your legs are, you're just going to multiply it by the square root of 2. Right? It's just a substitution problem. The problem is we know what the X on the square root of 2 is. So we're going to have to find a decimal. These 2 things equal each other. So if X times the square root of 2 equals 10, how do you solve that to get X by itself? So let me ask a different question. Let me make it look a little more normal. What if I had 2X equals 10? How would I solve that? Divide by 2. So if I've got the square root of 2, can't I just divide by the square root of 2? So if it was just a 2, that would be 100% right. So go to your calculator, 10 divided by square root of 2, and we get 7.07. So those cross out, and we get X equals 7.07. That's my answer, 7.07 and 7.07. Yeah. I agree. My zeros look all kinds of crazy. That's it for that slide. With that slide. Seven on the square root, or 7.07. Uh-huh. What were those asking for? OB and BY are those side lengths, right? So Mariah's already reading. Y equals 1. So let's label that. Is that the short side, the medium side, or the long side? It is the small side. So how big should the long side be? If we know the long side is half as big as the longest side, or the short side is half as big as the longest side. Okay, so let me back up. Let's make our little hashtag. We've got a 30, 60, 90 triangle, right? Small, medium, large. The small side is always X. The big side is always 2X. And the medium side is always X on the square root of 3, because I've got 3 different angles. So for 30, 60, 90, it's going to be square root of 3. For 45, 45, 90, it's going to be square root of 2. Opposite that 30 degree is 1. So where do I put the 1? The left, the middle, or the right? Absolutely. So the 30 and the 1 are across from each other. So they go across from each other in the table. That means X equals 1. Everywhere I see an X here, I can just put a 1. So 1 on the square root of 3, and 2 times 1, which is 2. So which number or which letter is 1 on the square root of 3? B is, absolutely. So that's square root of 3. So we've got square root of 3. And then where do I put the 2? Mm-hmm. The next part is the tricky part. You ready? If I bisect, if I cut 120 in half, what's the measure? There is a 90 here. I cut 120 in half. Mm-hmm. So that means this is 60 and this is 60. Beautiful. So if we know that the 120 we can cut in half to get 60 and 60, and we know that it's a right triangle, then what is this acute angle up here? You should feel smart. And if we know that the hypotenuse of that blue triangle is 2, where can I put the 1 in the square root of 3? So that's 1. Boom. Yep. And you can just leave the square root of 3. So that means that this blue triangle and this red triangle are going to be the same, right? So that's going to be the square root of 3. That's going to be 1. And this is going to be 2. So A is this whole, or C is that whole distance. If it's the square root of 3 plus the square root of 3, that's going to be 2 times the square root of 3. And then A is just this distance. So how long is A? 3 would be the whole thing. I think it's just 2. It's unclear if A goes the whole distance from corner to corner or if it's just that piece from the 60 degree kind of intersection. The next one you can do 100% with Pythagorean theorem. What? So what do you mean they look the same? I think the sides are equal. So if there's a 1 tick mark here and a 1 tick mark here, if the bottom is 7, then the side also has to be 7. So now I've got 2 sides. How can I find that diagonal? Absolutely. 7 squared plus 7 squared, and then take the square root. 9.9. So this side is 9.9. And that has 2 tick marks in it, right? So what's this side also with 2 tick marks? 9.9. So now we can use Pythagorean theorem. 9.9 squared plus 9.9 squared, and take the square root. So this 3 tick mark side is 14. So what else can I mark? And then what do I do with the 14s? That is how the first one is. Absolutely. It's just that times like 8 of them. Yeah, I won't be here. So if you guys want to work with each other, you're going to have to figure out how to get in touch with each other and set up your own Google Meet or, whatever, Google Hangout, FaceTime. You don't? You can work by yourself. Yeah, you guys can work by yourself. I'm just trying to check the time. 12:35. Oh, we have good time. Are we ready to go on to number 8? Hopefully, because I already moved my screen. Okay. There's no picture here. What should I do if there's no picture? I got to make one. What kind of picture should I draw if I'm talking about cosine and sine? A right triangle, absolutely. They only work with right triangles. So automatically draw a right triangle. And this is where you're going to take your information and put it into a picture. So this is kind of working backwards, and it's going to be a little challenging for a second. So if we remember, ka and toa, right? Cosine is cosine. Oh, that's not what I meant to do. Hello. Cosine of my angle equals A over H, right? So cosine of 40, I can put my 40 in there, equals A over H. So what can I put in the denominator of that whole number to make it stay the same? Like if I have a slope of 2 and I need to make it the perpendicular slope, I've got to do it upside down and add a 1, right? Can I add a 1 here? Can I? So what I'm trying to do is make this A into a fraction. So it matches my A over H. Can I do that? So the A is going to be my adjacent side. So this is my adjacent side. So I'm going to make that A. And my hypotenuse is 1. So my hypotenuse is 1. I'm just taking that ratio and applying it to my picture. So now my question is, what's the sine of 50? Where the heck are they getting a 50? Well, I don't know, but we've got a missing angle over here. What's that missing angle? The hypotenuse is 1, but what's the missing angle? 50. Why is it 50? Because 40 plus 50 equals 90. These two acute angles have to be complementary. They always have to equal 90 because we've got a 90-degree angle here that's taking half our 180s, right? So the sine of 50 is O over H. This is the O, and this is the H. So if I do O over H from the 50 degree, isn't that still A over 1? That's my answer. Mhm. You could. Because these numbers add up to 90 degrees, the cosine of 40 is going to equal the sine of 50. The cosine of 10 is going to equal the sine of 80. So as long as those numbers add up to 90 degrees, the sine and the cosine will be the same. It is a little confusing. So in the next one, because I don't want anybody to really break their brain, we're going to do the exact same thing. There's no picture, so we're going to start by drawing one. We're using sine, cosine, and tangent, so we know we need right angles. So that makes our life easier. We aren't given the 40 degrees like last time, but we're given an X. And then my problem part is here. That tangent of X equals a decimal, and I want the tangent to equal a fraction, O over A. So what can I turn 0.75 into so it's a fraction? Is it 1/4? 3/4. Love it. So my tangent ratio is O over A. So if I'm standing on my X, my opposite side is 3, and my adjacent side is 4. And how do I find the hypotenuse? Pythagorean theorem. So I've got a leg, and I've got a leg, and I want a hypotenuse. The triples! So now what's my question asking? So all it's asking me for is what is that ratio? Adjacent over hypotenuse. Is A over H. A over H. And what is my A? The 3, the 4, the 5? The 4. And what's the H? Boom. That's my answer. Okay. You can screen capture it too. It is a lot. It is a lot. I'm glad you guys chose to do it together. I think that was a smart choice. We ready to go look at number 9? Okay, we've done a bunch of these now. So these are going to be kind of similar. We're going to have to draw the picture and then label the picture. So how do I start? Boom. And then what do I know about that right triangle? Yeah, A and B don't matter. Sterling, you got it? So side AB. So AB, the distance between A and B, that side, that's the hypotenuse. So what does the 5 represent? The O, the A, or the H? The A. So if I'm going from angle A, this is going to be 5, right? And then the H is going to be 6. So this is the problem. Remember when we had the 3, 4, 5 and we multiplied it by a scale factor, made it 6, 8, 10, or multiplied it by 10 and made it 30, 40, 50, or 60, 80, 10, 100? This is the same thing. So what can I multiply 6 by in order to make it 30? 5. So we've got to multiply the 5 by 5 in order to make it 25. So the length of AC is going to be that 25. Number 10 is crazy looking. So let's see if we can make it a little less scary. So we know we need to draw a triangle. We know it needs to be right because we've got tangent, right? Normally, tangent of our angle is O over A. And all I see is an M. So if the O is M, what can I put under that in order to make it not be any different? M over 1. Right? M over 1. We've only done that once before. So you can always, if you have a whole number, add a 1 as a denominator to make it into a fraction, and then it doesn't change, right? So if I make this the x, just because we've been making that side the x, the opposite is M, and the adjacent is 1. Can we do Pythagorean theorem here to find the hypotenuse? A squared plus B squared equals C squared. The A is M, so M squared, that's my A. The B squared is 1. And then the very last step is to take the square root, right? But look at your answer choices. All you're doing is setting it up. That's why it looks scary. So now I want to know the sign of x. right? So what sign? Okay, so what's the O? The 1 or the M? Opposite is the M, so I know it can't be A or B. And then what did I get for the hypotenuse? Which one matches? Mm-hmm. +1? Boom. So sometimes the scariest looking ones are not the most complicated. It was still pretty complicated, but I don't think it was the most complicated. Maybe it was. Don't quit the team. You're not allowed. I'll hunt you down. Not allowed. No. Quitting is not an option. Perseverance is the only option. I'm a math teacher. I don't know how to spell that. I bet I could figure it out. Perseverance. That's at least close enough to get it right on a spell check. Nice job. A-N-C-E. A-N-C-E. We can do it. We can do it. So for 11 and 12, you at least have pictures. You don't need to draw a picture. So what can we label? Absolutely. And what else? AC is 4 because that's the opposite side of B, O over A. So now what's the sign of B? What's the fraction for sine of B? Mm-hmm. So what numbers would that be? O over H. Yeah. You were just, I think, a step ahead of us. What's the cosine of B? Mm-hmm. Mm-hmm. So all we did was find the ratio for the sine of B, which is 4 over 5, and the ratio for the cosine of B, which is 3 over 5. And then we're going to add them up. All we're doing is substituting. So what is 4/5 plus 3/5? 7/5. That is 100% what it is. Yeah. Absolutely. I couldn't have said it better myself. As long as the bottom part, as long as the denominator is the same, you just add them up. Answer is 7/5. Yay! I knew it was going to happen. Sterling, I feel like you already have an A in the class. Yeah, so why are we worried? Why are we worried about grades? What are we going to start number 12? How are we going to start that? Mm-hmm. So what do I have to do to that decimal? What do we do with the last decimal that was? Mhm. And sine is O over H. So the 1 is the O and the 4 is the H. So that's 1, and that's 4. But I've got the same problem that I had before. 1 doesn't equal 3. Bingo. So we got to use a scale factor of 3. So what's BC going to be? So 1 times 3 is 3. So 4 times 3 is 12. You're just multiplying the pink numbers by a scale factor of 3 to get the blue numbers. Done, done, done. There's 3 more. 3 more. I think so. What can I label in these triangles? So the ratio of B, so tangent of B, that's TOA, so that's O over A. Can I do 2.4 over 1? Okay. So if my opposite side from B is 2.4, and my adjacent side from B is 1, can you find the hypotenuse? Okay. So let's do Pythagorean theorem. 2.8, 2.6. That was what my memory said it was. Okay. So now I want cosine of n. So what's my combination of sides for cosine? So n corresponds to b. So I want the adjacent side over the hypotenuse. What's the adjacent side? And what's the hypotenuse? That's it.
That's the answer.
That's it.
That's easy.
My 4 words are dead. Like, they are dead.
Oh, something burned.
It is a lot. It is a lot.
I don't know what it is. My 4 words just don't do good.
Okay, slide 12. Yeah. All right, guys. What I want you to think about is this. We're going to deconstruct these points. If I start here and I go right 12 and down 3, isn't that the same as down 3 and right 12?
Yeah.
So this segment and this segment are both 3, and that segment is 12. And I got that from this point. Are you with me? Does that make sense? So just try to, you're doing a great job of sticking with me, even through the confusion. So if I go to A, I'm going to go left 3. That means this piece is 3, which means this piece is 3. And then up 5, which means this piece is 5. Right? So I got the blue numbers from point A and the pink numbers from point C. So now if I look at my triangle, how tall is my triangle? Hey. And how wide is my triangle? So what's the hypotenuse? 16? Did you guess that or did you do Pythagorean theorem? It's a good guess. It's a good guess, but let's do Pythagorean theorem. 8 squared plus 15 squared does equal 17 squared. You were very close, right? A lot of them are, but not all of them. So what fraction do I need for cosine? So cosine is adjacent over hypotenuse, right? So I'm going from C. That's where I care about. So adjacent is here. That's my 15. And my hypotenuse is always the same. So what fraction do I write? Don't give up. We're going to do one more. We're going to do one more. We're going to do 15 and then we'll be done. Yeah. Nope. So we have an equilateral triangle this time. So we got to be careful when we draw our picture. What do I know about an equilateral triangle? All the sides are the same. So if it tells me the base is 4, then all the sides are the same, right? What else do I know about an equilateral triangle? Oh, yes, ma'am. So what are all the angles? Yeah. Awesome. It is 60. You should be proud of yourself. What happens if I cut that in half? 30. And a right angle, right? Does that look familiar from what we were stressed out about in the first handful of slides? Does it look familiar with the 30 and the 60 and the right angle? No, no. If I cut the 30 and the 60 and a half to be 30, then what happens down here to the 4? Let's go to 2. And opposite my 30-degree angle is the smallest side, and opposite my 90-degree angle is the biggest side, right? So what's the height? 2 times the square root of? Why 3? Because it's in the answer choice. That's an excellent reason. What's another reason? How many different kind of angles are there? There's 3, so it's a square root of 3. This is a 30, 60, 90 triangle, so we're definitely going to have a square root of 3 somewhere. So now the question is, what's the area? So area of a triangle is 1/2 the base times the height. The base is 4. So 1/2 the base is 4. And the height is 2 and the square root of 3. 2 square root of 3. So what do you get when you put that in the calculator? So which one of these is going to equal 6.9? Are there any that you can eliminate because you know it's not going to be 6.9? It is A. So 4 times the square root of 3 is going to give you the exact same thing, 6.9. I thought you guys were guessing B like boy, not A like apple. And then it was not. And then it was not.